The word circuit means a path which starts and ends at the same point. An electric circuit is also something similar. Starts with a cell and ends at the cell. Along with the cell, an electric circuit might consist a switch and a load through which the current is going to pass through. In this case, the load is a resistor. Then you have the connecting wire connecting all of this together. You may add measuring instruments like an ammeter, which measures current. An ammeter is always connected in series with the circuit. And a voltmeter, which measures voltage. Voltmeters are always connected across the device you want to measure voltage. If I were to close the switch of the circuit, I would expect a current to flow. Initially, people thought that current would flow from positive to negative. This is known as conventional flow of current. But later on, with the discovery of subatomic particles, it was realized that it is the electrons which flow. Electrons being negatively charged, they flow from negative to positive. But we still follow the conventional flow of current, and hence current is considered to be flowing from positive to negative, opposite to the direction of electrons. Or you can say current flow is always opposite to the direction of electron. Ohm's law is one of the most important equations in electrical science. It states that voltage equals to current times resistance. How do you define power? Power is work done upon time taken. But in case of electricity, it will be very difficult to find the work done by the electric current. Hence, we need to have a maneuver. Let us do this. I multiply and divide by charge. As they both cancel out, I am not changing the equation. I switch the positions of charge and time. Now my equation becomes work done upon charge multiplied by charge per unit time. Work done upon charge is potential or voltage, while charge per unit time is current. So my equation for power becomes voltage into current. It is easier to measure voltage and current for electrical devices. If I use Ohm's law in this equation, I can further derive two more equations. If I replace the voltage in the power equation with IR, I get power equals to I square R. If I replace the current in the power equation, I get power equals to V square by R. A series circuit consists of devices connected one after the other. When we close the switch, we would see a current flowing through the devices. A charge moves into the battery where it gains energy, then passes through the devices. Here, the cell has the capacity to provide 10 volts. Hence, the charge flows carrying 10 volts. It passes through the first resistor, losing some of its voltage there, taking the rest to the other resistor, losing it all over there. It moves back to the cell, and this process repeats over and over again. What do we see? We see that the charge has to spend its energy on two of the resistors. Hence, potential is divided in series circuit. But no matter how many number of charges flow, all of them have to flow to the same path, and hence current in both the resistors remain the same. If one of the resistors stops working or is damaged, the current will not be allowed to flow as there is no alternate path. The combined resistance for a series circuit is given by adding all the resistance up. EMF and potential difference. EMF stands for electromotive force. But don't be fooled by the name, it is not a force. If you look at the circuit from before, the battery which is labeled 10 volts means that it is the maximum voltage it could provide for the circuit. EMF is defined as the maximum energy a cell can transfer per unit charge. In this case, 10 volts is the EMF. When you close the switch, the current passes through. It starts off with 10 volts, but it loses some energy and there's a drop in its potential. So the 5 volt which drops across the resistor is known as potential difference or potential drop. In parallel circuit, devices are connected between the same 2 points. When you close the switch, you will see a current flowing through. But here, the current has a choice. It can either go for the first resistor or it can choose to go from the other resistor. Hence, you see current gets divided in parallel circuit. But as the current does not have to pass through any other resistor, it transfers its entire voltage to each of the resistors. Hence, potential or voltage stays the same in parallel circuit. Combined resistance in parallel circuit is given by the equation 1 by R equals to 1 by R1 plus 1 by R2, and so on and so forth depending upon the number of resistors connected.